Ladies and gentlemen, boys and girls.
Children of all ages.
Thank you. Today we are working on our thinking problem. We're going to go through it step by step together. As you'll notice, it's not a 30-second problem, which is most of what you want to do is finish it. If you can't do it in 30 seconds, then you whine. Right, Delaney?
I don't know what you're talking about.
She does. She knows what I'm talking about. All right, allow me to read the problem first. The problem says, a bakery ordered 123 crates of eggs. So on your paper, if you don't have circled, underlined, highlighted, something to identify 123 crates of eggs is important, do so now. Savannah, you don't have it underlined, circled, or highlighted. So when I just said, if on your paper you don't have 123 crates of eggs, circled, highlighted, underlined, something to let yourself know that it's important, do that now. Benjamin, is yours circled, underlined, or highlighted? So yes or no? Yes?
Yes.
Okay. Each crate contains 36 eggs. Another important piece. If you don't have 36 eggs in each crate, do that now. When I walk around, if I don't see this, I'm going to take your recess away for about a year because I'm giving you time and telling you step by step what to do. Okay? Estimate to find out how many eggs the bakery ordered. So that's one thing we have to do. We have to estimate the number of eggs. Then find the exact number of eggs the bakery ordered. So those two things should be identified as important. That you have to estimate, that you need the exact number. So you might circle estimate, you might circle exact, so that you know you have to do both of those things. Both estimate and exact. Thirdly, you need to explain how you know it is reasonable. Explaining how you know it is reasonable is going to be done in words, sentences. No drumming with your ruler, please. That will annoy me. So if your paper that you're working on doesn't have the estimate we get up here, the exact answer we get up here, or an explanation that makes sense that we talk about, you're going to need to fix it. Questions? Awesome. So crates of eggs, 123, 36 eggs in each carton. Oh, David, can you tell me how you estimated the number of eggs?
First, I got 3,078.
That doesn't tell me how you estimated. What did you do to estimate?
I knew that 30 times 100 was 3,000, I just guessed about it.
You just guessed. Well, an estimate has some mathematical thinking that goes with it. Tucker.
I rounded.
Okay, he rounded. Okay, so if we take and we round 123 crates, and we round the 36 eggs in each crate to, let's say, 40. So we're going to round 123 to 120. We're going to round 36 to 40. And this is going to give us an estimate. Now, a trick that may save your life someday. If some bad guy's about to push you out of an airplane and he says, what is this multiplication trick that I can use when they have zeros in the ones place of the numbers when I'm multiplying. Jesse,
It's called the zero rule.
the zero rule. And explain to me the zero rule, Jesse.
A zero rule is when you're multiplying numbers that have zeros, you take them away and then you multiply the rest of the numbers. And then when you get the answer, aka the factor,
The product.
yeah, product, you add the zeros and then you get the answer.
Okay? So that's the zero rule. What I can do, and I'm just going to do it the opposite way of you said it, okay? What I can do is I can take the zeros that we find in the ones place of the factor. The factors are our numbers we're multiplying together. I can take those two zeros down and I can put them in the answer. In this case, there's a 0 in 120 and a 0 in 40. So I have a 0 in the ones place, a 0 in the tens place. Now, if I know my multiplication facts, I'm done with this and I'm done with this, and I know my facts, 12 times 4 is?
48.
48. Good. So I'm estimating, based on what Tucker told me, we're estimating that we have about 4,800 eggs. Are we going to have exactly 4,800 eggs? No. My answer when I estimate needs to be somewhere close to 4,800. But estimation should be shown on your page. Not, I'm just going to pick the number 68 out of the air and write 68. No. There should be some math that goes into an estimation. Let's look. Does that seem like a logical amount of eggs a bakery would order?
Yeah.
That sounds reasonable. I mean, they're a bakery. They use a lot of eggs in everything they do.
Yeah.
So, I mean, if I got 7, do you think they'd order 7 eggs just to come deliver and there'd be 123 crates and there's 7 eggs? So no. That's not even reasonable. If I got 4,286,912, do you think that's a reasonable number? No. No, I don't. Where would you even put those eggs? You'd have to have a freezer bigger than this room. So that won't work. Or a refrigerator, I probably meant. Now, the exact number of eggs. Lizzie, how did you find the exact number of eggs? You divided. What'd you get when you divided? Okay, can you have a remainder of eggs? Can you have a part of an egg? No. And if you divided, let me ask you this, Lizzie. If you divided, is your answer reasonable? Does it sound like 123 crates with 36 eggs in each crate makes sense that it would be 100 whatever eggs? No. Okay? So let's ask someone. Reed, tell me how you solved it. That Reed.
Okay, first I did 100 times 336.
Okay, 100 times 36. So you put 2 zeros and added 3,600. Okay?
I did 20 times 36.
So 20 times 36. Put your 0 down and you get 72. 720.
Then I added that to 3,600.
Okay, we add that together. The 3,600 plus 720. 0 to 13, carry 1, so 4,320.
I did 3 times 36.
3 times 36. And what'd you get when you did that? I'm too lazy to work it out.
108.
108. So you added that in. So you got 4,428. Okay. What he did is he used a break apart method. It's kind of like expanded form. He took the number of crates and put it in expanded form. So 100 crates gave him 3,600 eggs. He has more than 100 crates. Plus, the 2 is in the tens place, so the value of 2 would be 20. So 36 times 20 is 720. And then we have 3, because that's in the ones place, the value of the 3. And 3 times 36 is 108. So that's one way you can do it. Some of you, or some of the ones in my first class, used the lattice method with the boxes and the diagonals. Okay? I'm going to show you just the regular multiplication, because Reed's right. We just do regular multiplication. So let's look at that. Now I'm going to tell you, and I'll probably tell you this 4,287 times. If you know your one-digit multiplication facts, 0 through 9, you're never, and I mean never, going to get them wrong because you don't know what you're supposed to do. You may get them wrong because you make a silly mistake, but not knowing what you're supposed to do won't happen. It won't happen. Because all you need to know is your one-digit multiplication, you need to know how to add, and you need to be able to line up your place values. If you need graph paper, see me, and I'll get you graph paper to help you line up your place values. Okay, we start with our ones place. So the bottom factor, which is 36, the ones place has what number? The ones place is what number? 6. So I'm going to multiply my 6. Now, Savannah, you're with me, right? I'm going to multiply my 6 times 123. So what is, and I'm going to do it one place value at a time. What is 6 times 3? 18. If you know that, then you're golden. We have an 8 in the ones place. I carry my tens place. Again, it's just like breaking it up in expanded form. That's why we started with this. 18 is saying 10 plus 8. Expanded form. Okay, now I do 6 times 2, which is
12.
Plus 1 is
13.
13. Put down my tens place. Carry my 1. Because 13 tens is the same as 130. Okay? Now I multiply my 6 times 1, which is
6.
plus 1, which is
7.
7. Okay? So all I had to do to begin is multiply my ones place through those 3 digits. My factor of 36 and my factor of 123. Now I'm done with my ones place. I'm done with what I carried. Now I'm moving to the 3, which is in what place value?
10.
Tens. Since my 3 is in the tens place, I need to put my first number in the tens place. I need to put my first number in the tens place. So I have to put a placeholder here, or a 0, so that my place values are lined up. And this is why you see some people put lines down it. Okay? So now I'm starting with my tens place. Savannah, you're not watching and it's annoying me. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. And so what I just did is I did 30 times 123. And I got 3,690. I did 6 times 123 and I got 738. So if you can do your one-digit multiplication and you can add, you will never have a trouble knowing how to do this. Now I add my ones place. 8 plus 0 is 8. My tens place. 9 plus 3 is 12. Carry my 1. My hundreds place. 1 plus 7 plus 6. 14. Put down my 4. Carry my 1. 3 plus 1 in my thousands place. So we should have gotten an answer of 4,428 is my exact answer. Is our estimate somewhere in the ballpark of 4,000 or 4,800?
Yeah.
Yeah, it's somewhere in the ballpark. It's somewhere near correct. Okay, so we're doing all right. And all we had to know, well, we learned the zero rule. Jesse taught us that. Easy peasy, raw chicken squeezy. Okay, and all we had to know is one-digit multiplication. And hope you wrote this down as we were doing it, which I know certain people that are sitting right by me didn't. And then you had to know how to add. Line up the place values and add. Get it? Got it? Good. Good, good, good. Peace out. Love y'all. Have a blessed day.